Well, second session is about classes and objects. So here's the outline. In this session, what we are gonna discuss online is structure, and then we will go to classes, about constructor, destructor, and what are the difference between protected and private, and data members, function members, and how to access objects. And this is the dot and arrow operator, what is the difference between them. And then we have kind of the canonical classes and copy constructor, assignment operator, derived classes, polymorphism. And the purpose of this session is like why we need structure, and then why should we move to classes from structure, and then we will go through the basics of classes, and then about is inheritance and polymorphism. So first is about structure. I mean, till now we have learned the basic things like how to declare variables and input output manipulation, arrays, pointers, and loops. So here we are doing some programming, like suppose we have to program a simple complex number thing. So we have like real part and imaginary part, like C, and we are defining it like C is for complex and 2 is like real, one for real, one for imaginary, and we have C0.5 is real part and 1.11 is like imaginary, so it represents 0.5 plus 0.11 G here. And then we are implementing a function to add two complex numbers, and we have put here like add complex numbers, first complex number, second complex number, and then our result. And here we are just adding them. So here, I mean, if you see, the function is not, you know, well defined, even not body. So can you find the bug here? Yeah. Which one?
Yeah, just on line,
exactly, but it's like hard to read and debugs, but because compiler is not gonna complain about that. So next, here we can do improvements, like we can define real part, imaginary part, like 0 for real, 1 for imaginary, so we define there. And then we have typed up for float complexity, and we can use like complexity for C, defining the complex, and we can define real and imaginary like this. And if we are gonna use our same function, we can define like complex C1, C2, and then result is the same like this. And here it was a bug. So now we can find it's a more readable, but still it's not enough, because when we know we have polar form and then complex Cartesian form of complex number, and if we are gonna work on that, first we have defined real imaginary for Cartesian one and modulus an argument for polar one, and here complex and polar. There you need to consider like it's float type, both are of float type. So, and if we are using this kind of program here, now we are reading complex number, we are defining polar, and we are converting complex to polar. Here we are converting C, this complex, to X, this polar, and doing something, and then adding these numbers. Here we are taking this polar X, but add complex is for complex number addition, and we are using X polar, complex D, and Y complex. Here compiler is not going to complain anything, even though we are using polar, because it's a float type. It's just float an array at 0 or 1, so it's not gonna complain. So here is a kind of problem. So that's why we should move to structures. Here, what is the structure? Structure is a kind of variable you can define, it's user defined, and you can use different type of variable to store inside that. So here is a kind of structure to define the syntax. You can use variable structure name to access that. It's a structure object you are defining here to use this thing. And this, yeah. And here is a small example for the structure. Like we have defined a structure database which has number, age, and name, and you are accessing this using the employees kind of object. You are using database structure, and you are using here object, and then you are just accessing the data members of structure here and initializing them or doing some operations. So with the previous example of complex, we have defined two structures for complex and for polar, and now we can use at complex and complex 1 and 2, and then we can return the result. It is much nice. So it will detect the error and it's more readable as well. Now here functions and structure together. We have a structure like complex, then we can define our functions like add, subtraction, multiplication, division, and blah blah. And we can use this kind of thing to access to define our different function. We are adding blocks in our function, but I mean it's kind of ugly and it's a kind of boring as well, as because every time we are repeating complex, complex, and complex and complex to do a computation. So that's why we move to classes. Yeah. So classes is like how to explain this? Okay, we have ATM machine and we access, like we retrieve money from that. So we can say ATM machine is a kind of class, and we have our card, debit card. We can say we are put that card in that ATM machine. So we are creating an object. We have object, and we are putting that, and that machine shows like your all information. So it's accessing actually this card. Here comes inheritance. I will come to that later, but it's creating object, and with that you can perform any kind of function that has that class has, like you can retrieve money, you can get your statement, or you can do like retrieve money with the with receipt or without receipt. So these kind of functions you have in that. So you are actually accessing the functions of that class, and then afterwards you just remove that card. It means you are disrupting that thing, and when you put that card inside, you are going inside the constructor. It initialize your card. So it's a kind of simple example. So what are the classes? It's a user defined. It consists of 0 or more members. It's like a data members you have, function members you have, so and type members. What are data members? These are the objects. These are the objects. And function members is operations you perform on the objects you have created for the classes. And type members, these are associated with the class. It means the classes inside the classes. It's a, how do you say, it's a nested classes, you can say. And then there's yes, our objects are represent, when you create objects from the classes, it represents what kind of operation you can perform. You can perform the operation that are defined in the classes on that object. And there are access specifier, which actually tells you what kind of control you have on the data members or functions. So there are three kind of access specifier: public, private, and protected. Public is like it's can be readable by any other code as well, anywhere. So it's a public. Private is only accessed by the class and its data member, or if you have defined any other class or functions by friend, so only those can access these things. And there is another called protected. It's a function of inheritance. Means if you have inherited another class from the base class, then they can access these protected data members or functions. Yes, structure is a kind of class. So how it's same, we will see here. So it's a typical class declaration. How we declare, like class is a keyword or reserved word we have, and my class is the name of the class. Then we have public and private, and you can also add protected here. So public is public members, but in public, just remember you must declare the functions and try not to declare any data member here. So it's a bit risky to declare data members in public. In private, yes, you can define private functions and your data members. In protected, it's the same like public. I mean, it shouldn't be like you shouldn't declare the data members in protected. I mean, you can access inherited classes can access from the base class, but it's a kind of risky like in public. If there is a friend class or friend function, then they can access and it can just do something. So it's a, here I have put 4 blocks. First and second are similar, and C and D is similar. If you are just declaring the class like this, you are not declaring any specify like public or private or protected, then it will consider it like a private member. So it's always private. But if you are declaring like public and private, it will consider them like that. What is the similarity between class and structure? It's like this. If you have structure like we have defined before, and you are declaring all the members as public in class, then it works as a structure. So here is a kind of same example. Here class complex, and we have just put all the functions together. Here add, subtract, multiplication, division, and here is a data member, it's a real and image. It's a kind of private, all the things. Now it's much shorter, much readable, I guess. And when we are using this add function, here we are just returning the result and we are inputting one complex. It works on this keyword. It's a kind of hidden, but it's this keyword. When you are creating object like complex or some object, then you can use the either dot or arrow. It depends on how you declare the objects. So you can use that, and this action will perform on that object. So it will take that value and the function inside value, and it will return the result. Now constructor. So when you declare any object, it must have initialized some value for that object. So these constructor does that thing. Yes, and it prevents actually from accidentally unused being used before it initializes. I mean, if you don't initialize it when you are declaring it like an object of the class and you already have declared some kind of values before, so it might be risky to use that afterwards because it's not exactly what you are going to do. So that's why we use constructor. So it starts with the initialized value what you have put inside that. And then constructor has the same name as class. It doesn't have any return type, not even void, and it cannot be called directly. Constructor can be overloaded. It means you can use 2 or 3 constructor based on their parameters. You can put the number of parameters inside that. So it's overloaded. If you are not going to provide any constructor there, then the compiler provides a normal, automatically a constructor, but sometimes it's not a good constructor. You cannot say it's gonna work as you want. So yeah, without if there is a constructor without any arguments inside that, it's a you can default constructor, you can say. So here's an example for the constructor. We have a class for vector, and default constructor is like this, where every values are defined like 0. I mean, yeah, and then second, another constructor, I'm defining it double x and y, and I'm just passing this value to the data member. And then here, these are the data members. I have defined x and y in private sector. And in driver code, in main code, how it's gonna work, here vector u is just calling the vector u. I mean, it's creating u is a object, is creating object. It has value x equals 0.0 and y equals 0.0. It just invoke the main default constructor there. And then second is vector x, and then parenthesis is declares function x which returns the vector. And the last line is vector 1.v 1.0 and 2.0. It invokes the second constructor where it just put like x equals to 1 and y equals to 2. Second,
this function x, you can call it after, like it was vector, like v, like you can use, how do you call x? Like,
this one?
Yeah.
Yeah, you can call afterwards. It's just a kind of like I'm just saying it's a function that returns the value of the vector. It's like, it's okay, I haven't defined here this one, so it will like x function here and return the value of vector. So it's a kind of thing. So. And destructor is the same like constructor. If you are constructing something, if you are initializing something, you have to destruct in terms of memory. Yes, you have to release that memory. So it's also provided by a compiler. It's automatically, and it's normally used to clean up that memory. and when destructor calls and memory got released, it ensures that the resources allocated to a object must be freed. I mean, it's just release all the memory files and devices and so. And how it defined with the name like this. It's this curly thing. So I don't know how to say it's a curly thing. So it has things like, and Destructor also doesn't have any return type. It doesn't have like a return type, and it cannot be overloaded because it's always one, because it's just a destructing thing. It's just destroying the object. It's releasing the memory, and Destructor doesn't take any parameter. Normally it's called automatically, so you don't need to do anything. You just need to define Destructor somewhere. If you are using some dynamic allocated memory, and you just in Destructor you have to release that memory, and after program it will destruct it automatically. So
Sorry. What the destructor is called, is it the same mechanism as the scope of the variables?
yes, but in
I mean,
yeah,
I
no,
don't
no.
know if it is the same mechanism, but the destructor will be called at the end of a block or a function or well, a scope of
When you scope of the object.
Mm.
So it's called, and it's like a dynamically, when we normally use pointers when we use like a thing or objects. So we are just pointing our object towards the class, and we are initializing the values. It sometimes takes memory in memory space somewhere. It's dynamically allocated. If we are not using this destructor, the memory always be kept by that object, and it's not gonna release that memory even it's out of scope. So that's a disadvantage of pointer or something you can say, because always related to pointers. And if you are using destructor, it's a kind of way not to using that delete option or something. It's automatically done afterwards, and it releases that thing. So it's in terms of memory, it's important. Yeah, if it's not defined in your class destructor, then the compiler automatically create the default one. Here is a destructor example. So in class, there is a kind of buffer pointer which has created some space in memory, and in destructor, you have to delete that space. And yes, so protected versus private. So here we have two kind of excessive identifier, which actually define like what kind of uh, access permission we have to access this data member or function member inside the class. So for the protected one, they are not accessible outside the class, but they can be accessed by the inherited class or the friend function. And for the private one, these are not accessed by the class inside the class, or I mean, they are only accessible by one class. If one class has defined the private one, these private members can access by its function members only, not by the other classes or other classes or inherited classes as well. So what are the data members? When I say data members, so it's like when we declare these kind of things, variables. It's a kind of variables of class. These are the data members. So here's we have X and Y and data members, and I'm just performing some stuff and setting data for the data members of the vector. Static data members. So sometimes we have functions that are only accessible by those classes, or we have to put objects there to access these or inherited classes. But we need some code should access our functions in the class as well, instead of writing again those functions. So we put a static keyword there, we make them static, and any other functions can use that functions in the class which are static. So here is the examples. to use the static. So for data member, here's static, and it can be used by any other member. And there is a function. Yes, it was a data member. Here's a function. Sometimes we need functions that doesn't operate on the objects of the class, and member function of the class doesn't operate on the objects of class, called static member. To make member functions, we use static. It's the same, I guess. Yeah. Here in this example, we are using this static word for the function here, and we are defining like here we have the variable random, and we are using random with degree to gradient here. And if we use like a object and we perform it on object, it will ignore that object because it's static and it can work on any code. So, and here is the function member. So function members are the functions which we declare in the class. These are the function member, like void initialize is a function member here. As name suggests, it's a function, so it's a function member of the class. And we are I'm just initializing this x and y here. And when I'm calling here, it's a vector tool. It's b is just create vector and call b. And here I'm initializing the value to the vector. Here dot and arrow. So there are two ways to call the function members or the class. Is dot and arrow. Normally dot is work on the actual object and arrow is works with respect to the pointers. So here is an example for that. We have a class, we have a function member, we have a data member here. I'm declaring objects here, two types of objects. For class A, it's a actual object here, and I'm calling a this function, so it will give me b equals to 5. So
No, I can't read this. In fact.
Okay.
I mean, the line below int b.
It's
I don't understand this.
It's a function. I mean, a parenthesis. It's a class function like a and parenthesis, and it's just a function. I should have write it in the different lines, but it's a kind of function. It's just giving a b equals to 5. So it's just like putting value in a b, and here is the data member b of the class. And then here I'm creating object a, and I'm just calling this function using that object. And so it will give me b equals to 5 is the data member. And here is another, I'm using a star x, I'm using pointer with respect to the class, and just putting the address of this object here, which I created the actual object before. And now I'm pointing towards the value of b, which is the data member, because every object you created from the class, it has access to the data member or functions in the class. So I'm just calling data member using these two objects, and it's a different way of calling. It's a point and it's an arrow. So it will give you the same value. It's just a way of calling them or creating the objects. Question?
Can you also use and in the second line?
Yeah.
No, the a big A star x equal.
Mm-hmm.
Can you do and a parentheses? Like
like
instead of doing a
here.
Yeah, basically putting that below. Yes, like in one line, like
Capital A.
capital A parentheses next to the ampersand.
Next to the ampersand.
Yeah, like doing one like basically. Is it work?
I don't know. I never tried this thing, so I normally be specific, like doing stepwise things. You can try.
Okay.
That's a good one. I can try it. Okay, canonical classes. It's a kind of classes, but there are certain kind of rules or checklist. Whenever you design a class or you are writing about a class, you must have a checklist with you what you have to put. So they are like, you have to be sure you have put constructor there, you have put destructor there, you have put copy constructor there, and you have put assignment operator. It's plus 98 structure. If you go further, plus 11, there is a move constructor, there is a move assignment operator as well. So I'm not gonna talk about the move, but I will talk about these things. Destructor and constructor I already tell you, but I will go with copying constructor and assignment operator. Copy assignment operator, I would say. So these are the basic class things, and if you are not declaring them, then compiler will automatically declare these things. So here is a copy constructor. What is copy? Is just used to copy the existing objects to the thing. And the copy constructor form is like defined like class, constant class, and sign. St is a kind of template. I will tell you later in next session maybe. So it's define the template. It's a class, and if no copy or move constructor is not there, then compiler do that the same. Here is the copy constructor example. So we have default constructor, we have another constructor we have, and now here it is copy constructor. So we are just copying a value of vector x and y to x and y of the data members of the class. So how we are gonna call it? We are gonna call it like, first we call if this constructor, then we are calling like v 1.0 and 2.0. In the second line, we are calling vector w in bracket v. It means I'm copying this vector value to w object. Or is the same thing if we are gonna say vector z equal to v or w equal to v. It's the same thing we are doing, is just copying the things. There is another copying assignment operator. So here it's have only one parameter, and that is L value reference. Okay, I must tell you what is the L value and R value. Here's the thing, L value, and another is R value. L value refers to AND operator, like I'm using T class AND to define the copy constructor like before here. Constant vector and v. And for R value, it should be like vector and so it's double N when you define move, but it's in C++11. So it used to assign already exist value to another object by copying. So in no copy assignment, I mean, it's the same, like compiler will give you the default copy constructor, and you define normally using this operator. And here's an example for copy assignment. Here we have copy assignment. Here we are using this. This is not equals to NV, so it's a kind of condition. And then we are calling here the call vector. Here we are calling constructor. Here we are calling again the copy constructor with 2 lines. And the third one is like we are calling again the constructor with the double and double. And here we are just copying the things because we are not using this value. Now we are copying this value to this value. So it's a kind of just copy assignment, like name suggests, we are assigning values, and it was constructor, copy constructor. Okay, here is a class for exercises. You can download from this link. You need to do this exercise.
Yeah, you got
You need to explain.
Yes. Yeah, you then it's an exercise to write a class. First of all, we will write the rectangle class. A rectangle is defined by 2 points. and the exercise is to write a class. Before, after that, we will transform this class in a canonical one. Okay? Now you will begin to download the exercise and to write a rectangle. Is it clear or not? Not so much.
I have some questions for
Yeah.
on what you said. The first one is I don't know if I should now or not. The question is, you said that the objects and they are created in the location. Does that mean that every object
Yes.
any object?
Yeah. I mean, I explained so it takes some memory to do operation in some memory. You do your operation.
You have a class. You have a point class. Okay. The point is you have something. Point. And for point you have to coordinate.
Simple
Yeah, it will do it.
What is your advice? Should we always write?
You have to coordinate
Yes.
and right.
Yes.
And to have a rectangle, the rectangle is like that. You have not a rectangle like that. Okay.
But it doesn't
And
work like
this rectangle is defined by
it's
these
better
two points. If you have 2 points, you can define this points. So you just give 2 points and you print the info. But it's writing it's in the if you could you
exchange.
yes, because if I have my GitLab exercise, I can explain more. The GitLab, is it possible for you?
Can
I take mine. I will show you. But mine is not shared. My screen is not shared. Could you share my screen?
I'm
You are with because it's better with your PC because
so
it's
where you want to go?
share. Yeah, CPP Basic and download.
It's in exercise.
Yeah, in exercise download and rectangle class.
Should I need to open?
Yes, rectangle .h.
So
You have a class, point class, okay? And
okay, I don't know how to do this here. Wait.
can you share? To share the screen. I would like to share this screen.
Not here.
Tu parles français?
Oh ouais, un peu.
I would like to share this screen, but I would like to go in some files and to show you. Okay.
It's a Zoom.
Is this one?
No,
Sure. Why not?
it's a Zoom. It's a Zoom session.
Do you have an issue, Vanchika, with the session?
Yes,
okay, sorry,
we
I
would like
understood,
to share GitLab repository, but we don't manage very well.
What do you mean by sharing?
Sharing the
Oh, okay.
now you see the slide, but we would like
No,
to see.
I see the GitLab here on the remote.
Ah, you see the click slide?
but we don't.
We don't.
We don't.
Not
So I
Ah.
because we don't.
Okay, so you need to stop the sharing session, I think, and share your complete screen.
No. Yeah, it's working.
Yeah, it's work now.
It's weird. It's weird. Yeah, I need to stop sharing and then do it.
No, wait. I think
Okay.
it's fine. It's weird because
No, it's weird. I can share this screen.
Yeah.
We can see only one part of the GitLab here.
You can see
Here
the
we-
rectangle.
The
You-
rectangle, but half of the browser. It's weird. There is like a bug.
no.
Now it's working now.
You know the exercise.
Oh, it's okay. It works.
It works.
Yes.
Okay.
I need to be there.
So
Because now
I have
basically
not,
you're using the
yes, it works, but
GitLab.
I don't
can
see
see the
what I want.
So yeah.
but now it's fine. No?
You
It's
have
fine.
Yeah, but I don't know how to put it back. So
class.
Okay,
The
we'll be
class
sure.
take for
do
the
that.
constructor class. You take 1 point and another point. So this point here and this point, and you define a rectangle. Okay. And here you print info on the rectangle. You print the coordinate of the two points. And you can, but it's not obliged to move the rectangle. To move the rectangle is what? With translation. Yes, the translation is x equal x plus delta x. Yes, the translation in English in the text. And you do that. That's the first step. The second step is to move this, when you write this class, you move it in canonical class. But perhaps can we make the canonical class tomorrow afternoon? As you want.
It's up to them. So
As you want,
maybe-
because I will not be.
so we can do it now, or
Yes, I can do. We can. Okay. Is clear what you have to do? Yes. Do you need some help from me? Oui. Attends, faut déjà. Mais c'est juste que tu dois donner c'est-à-dire que ici, tu vas me prendre ce genre, tu vas lire, tu vas les donner.
No, it's fine. It's just
Oui. Tu dois dire le P1 et tu viens passer au P1. Oui, c'est tout. Si c'est ça pour toi, c'est bien. Après, Il faut un constructeur par défaut, un constructeur par défaut, un destructeur et un modérateur d'animation. Là, tu remplis ça et ça. Mais là, tu remplis ça, là, tu remplis ça. If you have the .h file, you must fill the .cpp file. Okay? You must fill the CPP. You must do it. Yeah. Vous avez juste à juste à insérer les infos. Alors, par contre, je ne suis pas sûre que tu peux remplir ce que je suis pas sûre. Oui, c'est ça qu'il faut faire. C'est le zéro qui va pas. Alors, Because you will see more. You see, if you have that's the is more or less okay. And see implementation.
I don't know.
Yeah.
I don't know anything. So, and where is it another?
The implementation can give by default it's okay, and you add what you have.
So it's something like this.
Yeah, and then yes, in okay. When you have a class, you have for each class, you have
If I don't put it,
yes, you have to compare. No, you have to change. For example, you have to yes, example.
yeah. Okay, that's it. And everything else?
Here you have
But then I say those are the CPP.
yes, yes. To compare, I will write. To compare, you
Make like that.
point. CPP. For example. Okay, you need to compile, you need the .cpp with the implementation. Okay. Some explanation?
Like this, basically. I'm just here.
But you can write to the rectangle.cpp.
No, not yet.
Okay. But begin by more simple, as you want, but you will begin by.
But what I should
Do you want to give the you have the here, you have the rectangle dot h, and in the rectangle access is more or less as an interface, okay? And we must implement the constructor, the method afficher info method and the déplacer method in the, .cpp. That's okay for all people? Huh? H header. Header. In C++, you have the header file. The header file, yeah, is okay for everybody. For at the moment, you have just to write this. You have you remember in .h you have the constructor. The constructor take two parameters p1 and p2, and you must affect p1 to p1 from this class. Here is p1. You remember you have rectangle class. Rectangle, you have something that you have pivot, plot, P1 and P2. You remember that? And this P1 from rectangle takes the parameter. And the same for P2. Okay, it's clear? You must do that, and you must, that's for the constructor. Yes, to print info on the rectangle, you must write P1. You must write X and Y for P1, P1, and X and Y, and I for P2. Okay, and you use the methods which are defined in class point. In class point, I will show you, but I don't know.
Sorry, Valerie, but we can't see. I don't know if you're in your code editor, but we can't see it with Zoom. It's not for me for the recording, but we're still on the GitLab interface.
You have to share the whole screen.
You need to share your whole screen, the whole screen. So when you will switch.
Quand you share, on l'a dit. Dans ce cas-là, tu peux basculer l'un à l'autre peut-être.
Here. But
Ouais.
j'imagine. You see now?
I see the browser with the rectangle.cpp in GitLab.
Yeah. And if tell me if I will move if you see again.
I see that you're browsing in the exercise. Yes.
Yeah. Okay. It's okay.
Okay. Thanks. Sorry for.
Yeah.
It's okay.
Thank you to tell me. You remember when for the method afficher info, we have write cout, something like that, cout, P1 get x. And P1 and get x is defined here in point. Yes, it's clear for everybody?
And how you compile the whole?
The wall, I write here, the wall is compiled here. You use G++ as usual, and you put all the CPP file minus O and the name of your executant. I should say that you use what you want.
The order of the C++ source file has no. The order of the C++.
I guess no, but it's better to put a point before because rectangle use point. But I guess no because the link is named after. It is okay for everybody? Yes.
So you check if you just forget the main.
Just a moment.
What's the const mean?
The const mean
After afficher info, for example. What is const?
here, for example, here or affiche info. Const means you can't when you affiche you implement affiche info. You must not change x and I because you just want to know the value of x and y, but you don't want to change the value. And to be sure you don't change the value, you put the keyword const.
It means, I try to reword.
Yes.
It means that it's a method that comes modified
Current.
now the object.
Yeah.
Any data.
Yes.
Okay.
It means that. Yes. It's
It's a security.
yes. Yeah.
There's also the
And
after affiche.
I show you in the
Yeah, okay. The const after the and not h. Just few lines.
yeah.
When you declare, okay. Void. No, okay. Okay, that's why there is a const after.
After is the same. Is we don't want to change P1 and P2 value.
When you use const, it means you cannot change the value after.
Yeah, but inside the parentheses, it means that, for example, in the second line, when you define the rectangle, like, okay, that's const point, it means that you cannot change it.
Yes.
Okay, but if you put it outside,
You can't change the value of the variable inside the method.
Okay.
It's just a security.
There is another word called expr. It's for standard 11, and you can also use it, but it's also varies in function. So we use this to.
Because here it's easy because const is a parameter. Here const means you can change the object here, the private P1 and P2. In rectangle, as you have P1 and P2 is an object of the class, and you must not change. And so you put here const. Is it clear? Yeah. We have not a parameter because the parameter are in the class. Yes, are here. It's more or less clear. So now you know to write rectangle class. Okay, you transform it in a canonical one. Yes, and if you can have a look to point. Point is a canonical one, and you can copy more or less point to transform rectangle .cpp in a .cpp and .hash in a rectangle, in a canonical rectangle one. Okay. Rectangle class must become a canonical class. To transform rectangle class in a canonical one, you can have a look to point. Point is a canonical class. You need proprietary constructor, constructor by default, an operator, and one destructor. So,
for example, so just if you don't change anything. How would you change that if I don't come here? Nothing. I'm not changing it. This word, where if I pass, for example, the address, I cannot modify this. I cannot modify it's the same as this.
Okay.
Underscore. But in principle, this is external ones. This is just a differential. But here it makes no sense.
Not exactly, but
I will explain you.
Yeah, I'm just thinking how.
I will explain on point, for example.
Look at line code. It has to
Here you have P1 and P2. They are parameter, okay? Yes. When you if you if you make an instance of rectangle, you make a rectangle, it's called you make an instance of rectangle, okay? And here you have point P1, for example, 1, 2, 3, and P2 what you want, and you find P1 and P2. Okay? But P1, this P1 is a parameter. Okay? This P1 here is an object who belongs to the class rectangle. There's not the same meaning. One in the class, it belongs to the class. The other one is a parameter. So you don't have to check to mix the both. To recognize this one from the class, you put the keyword this. Okay? This means I call the P1 from the class. I call the object of my class. Okay? This arrow P1, this is a pointer, so you put an arrow, not a dot. And this, you take the object of class. Remember, rectangle, you have a lot of things, but you have private,
2 points. Okay.
float, x, y. This is this. This means this one.
Okay.
This is not x, y.
It's
So
P1, P2.
P1, P2. Sorry.
We use x and y. It's this pointer x equal P1.
Yeah.
In case of we rename in the header class.
We like to have the same name because we affect P1 parameter P1 to object P1 from rectangle. And to have the same name, you must be clear on which is it. And which is it? This means this is the one of the class. It's clear now? C++ is not easy, for sure.
Still, in new versions of C, you don't need to put this keyword as well. So you just use P1. Yeah. But it's like complicated because P1 equal P1. So it's like
I think it's more clear like that.
yeah, but still it's like for me when you use this. So it's like okay, I'm this.
Yeah, sure.
So what I personally do is like when you're defining data members, you can use kind of like underscore, like here P1 underscore.
Okay.
In my all examples, because they are defined like 20%. So you can just differentiate like that.
Okay.
You don't need to put this arrow.
So in conclusion, what we use is to avoid this notation and to use the underscore. No, I have
In
done
H.
okay,
No.
okay.
In the
What is it? Sorry.
No, in the dot H.
The good practice is to ever you use this keyword. The good practice.
No, personally I prefer to avoid this.
Okay. Because it's in another language like PHP, this is mandatory. In Java, this is mandatory, and for me, it's a very convenient to use this keyword. Okay, but I just want to go the good practice.
No, it's from the first slide. I'm saying there is nothing good or universal rule to program.
Okay.
It's up to your convenience. Just personally.
So the one.
Yes, but I think it must be used with this and so on to remove.
Yeah.
Yeah,
So
but because we are used with C++.
Yes, because yes.
If you are not used with C++, I think it's better to put this to know what you.
I think if you come from another language like Python, because Python is a self keyword,
yeah.
and
Yes.
No,
The second keyword is
JavaScript you have the sys keyword, PHP you have the sys keyword.
So how I differentiate? I just put 3 and
Yes, I know. Or kind of 5
Yes, what is the third thing? Like the
First one is the
first
primary one. The second is for copy.
Yeah, third one is assignment.
here is
First one is empty.
by
Second
default
blank, and the third is
is
a copy.
Constructor.
yes
It's another user-defined constructor. You are just initializing value in your program. It's like a
here
constructor.
is not obliged, but it's
Yeah.
exhaustive constructor.
Yeah, it's a user-defined, not like a
Yes.
compiler-defined.
Here you have the constructor, the copy constructor, and here you have the operator.
It's a
Again,
copy assignment operator.
Yeah.
Copy assignment operator.
what is that?
What is it copy?
To
It's
affect.
Oh, okay. It's copying. Actually, you have already defined some object with some values, like say vector x and y value, and you have defined another variable like another object with same another values like vector, some another values. But you want the value inside that another vector the same as the previous one, so you just copy that value.
And when you don't you use the other one?
And what do you need the second one?
The other copy? I use like
What do you have? What do you must to have in mind?
Or the
It's
the operator.
or the operator is equal to.
yeah, yeah.
What do you have in mind to understand equal? Is a class is made to make a type. A type. You have type like int, float, and so on. But the class, the topic of class is meant to make a type, like a type. If you want something like a type, you must have equal for a segment. Yeah. If you have float, for example, x 2.2.1, and you have this equal. And if you want to make a type, you must use this affectation operator. Okay, you have more or less a type, and a type you must have an affectation operator.
And this one is assigning a rectangle that already exists, no? Or is
Yeah.
a new rectangle? So you have to do like rectangle, some name equal some rectangle and stuff.
Yeah.
Yeah,
Yes.
for example,
So I can exactly so like assigning.
to say yes, you must to have a segment.
But in principle, you can just do rectangle something and then something equal that
Yeah.
with the copy one alone, right?
Yeah,
You don't
you
need
have a
like
No.
official.
It's not the same because the constructor, compiling constructor is not the same of an assignment. A compiling constructor is to create an object. If you have two objects, you can affect one object to another one.
Okay.
You understand? When you have a constructor, you make an you construct an object. You call that an object rectangle. But you can affect a rectangle to another one. It's like to declare X. Always remind a type because this topic is to compile type. Class is to compile type. Canonical class, the theoretical of canonical class is compile type. And if you can declare X, but you would like to know if you would like to affect Y to X, for example, for a float. Okay? And the same for rectangle. You want to assign R2 to R2 to 1. Understand?
I have another
Yes.
question. The first definition, except for the one, the first one you pass 2 points, okay, to create an instance.
Yeah.
Okay. In the second one, you pass a rectangle.
Yeah.
To create the same instance. May I use in the second constructor the first constructor?
I don't understand.
May I have in the second one? I just define P1 as the second one. The third one, okay, the third one. That's one.
This one?
Yeah, this one. In this one, I define P1 as the P1 of the rectangle that I cast.
I'm not sure to well understand what you mean, but this one is to compile one rectangle to another one,
Okay, that's kind
and this one is to create, because this
But
one
may-
you give P1 and P2.
Yeah, but in the RHS, there are 2 points.
Yeah.
Okay, so
No,
may I
it's
use
very-
the first
RHS means right and
passing the
right hand
Yeah,
side.
actually, you are using
RHS is
constructor.
right hand side because of the affectation, but it's a constructor.
No. His question like, can I use the constructor to copy here in copy one?
Yeah, may I use? I don't know how to do it, but may I write this the rectangle? I'm passing the RHS point 1 and RHS point 2 using the previous one.
No, you want to use this one in this one?
No, yeah, I want to use
This one here?
no, this one inside this one. Use the other one. The other one is basic. I mean, the rectangle is
This
defined
one
by 2 points.
in here? But you can because it's constructor.
I don't know if
If I
You
understand,
can, you
can
can,
yeah, if I understand, you want to use this one here.
Yeah.
So you want to use
inside the
this
definition.
rectangle thing here.
Oh, inside the definition.
no,
Inside
you want to
because-
call it rectangle. But rectangle is not a method, it's a constructor. And you can't call, it's not always right, but you can't call the constructor. Constructor is a special method.
Okay,
But it's not like a method you can call.
okay.
Yeah, it's just to initialize the value.
In the
Okay.
meantime, you can't. But
Yeah, but
some it exists some case, or you can call the constructor. But the constructor is never called. More or less, never called. The constructor is called by the compiler. No, it's not used. It's not a method which you could use.
the constructor.
Yeah.
The constructor it's a mechanism of C.
Yeah.
The mechanism of C is the constructor is called by the compiler, but not by you.
Okay.
When
But when
you
you call rectangle
When you
point
call-
point, that's calling the constructor.
yeah, no, it's actually a method to create object, and the constructor is
Yeah,
actually
when I call
called.
If
rectangle,
rectangle
one,
error
and I pass the
will call, but it's not you. called
Yeah,
this.
you are
Compiler
defining-
will call just a minute. The compiler will call this constructor. Okay? But you don't call it. The constructor, it's a mechanism that the compiler call for you the constructor. But the constructor is not a method like the other methods. You can't call. You just use it when you declare you make an instance of a class.
Okay.
So you can
You can call it internally then.
not.
It
It's
means
more or less right because sometimes you can call it. So but not usually.
Okay.
In very special case. But not here you can. So that for sure. Because you can't call a constructor by a constructor. You can call a constructor by yourself. Okay?
Can I ask you what does it mean NH is acronym?
Right hand side.
N.
right hand.
Okay.
Right? Right hand side because it's gay. It's affect, yeah. And you use it here to put here and here with the affectation. Right hand side means affectation.
There is no
Left hand side, no, because right, you don't write. Yeah, you don't write that. You don't affect x to 2.1. It's not correct. You affect this side to this side.
LHS is this is a mandatory acronym or can we replace it?
And you can replace it, but usually we use LHS. But usually, if you replace it by Toto, you can. Yeah. Sure.
Can you?
Yes.
Yeah, I got the answer.
Ça, c'est ici là que tu passes en fait en ici, je passe, si je passe
Ici, c'est le
And you can also
Here,
do
what I do is for my 2 points, I pass just a point one, I point to a rectangular class.
you can only
I don't know if it's okay, as you put it,
create
do something like here
or
rectangle.
assign it on a
Just cool.
That's why they did the third finish. Anyway.
Parce que c'est des constructeurs qui
It's not correct. I don't know if I I see the code is I don't know.
Voilà, ça
I probably there is something wrong
En fait, ce qui se rappelle toujours, c'est que quand je Ça, c'est le camp de l'application.
But you could use that
Oui. Voilà. Après, c'est des méthodes.
That's what I suppose. Okay, instead of using this here, in this one, I extract the P1 times P1. Okay, I just call the other one. Passing the points. It's not a constructor. I use a constructor instead of I probably
you also depend on, for example, like output if you do a flat thing, and then you kind of like
okay. Okay, but this commenting, okay. This commenting. So
And this is the second part of
you're not sure about
yeah, you can. It is not something about classes with the This is a good type of stress that you avoid to provide.
yeah, because in case of I have a lot of parameters.
I understand what you mean and what you want to do. What you want to do is a good way of
yeah, because you cannot call it explicit.
Yes, no, you can't call it explicit. It's called CCP compiler.
Okay.
I think for, I mean, at least for me, stuff, it's kind of like stuff.
Ah là, mais quand tu l'appelles, tu passes par le destructeur, je pense. Parce que tu vas détruire, oui, tu vas détruire
Oui,
tes
parce que comme
objets
c'est-
par
d'accord,
détruire
d'accord,
son force,
d'accord,
parce
ouais.
qu'il a été défini par un objet de sens.
C'est ça, voilà. Ouais.
Donc, quand
Ouais, c'est dans les membres,
ouais.
c'est aux attributs.
Could I correct rectangle? Is okay or you need time? It's okay? So, we begin by the constructor by default. The constructor by default is very easy because you do nothing. If you or you could do just one rectangle by default if you want. Here is the exhaustive constructor. You build a rectangle by 2 points. Okay, and you affect these parameters to the P1 from rectangle classes. So the object of rectangle, we'll talk about. Okay, that's clear. Here you write the copying constructor. There is a constructor more or less by affectation. Okay, you have a rectangle who is bound, and you affect this to P1 and P2. Okay, that's useful for a function. When you call a function, you copy the parameter to the function you call by the stack. Okay. Yes, and after that you make the assignment operator. Okay, like if you have a float, you make you write y equal x. Okay. Now this don't need for a canonical class, but this is need for canonical. This and the destructor you don't see here are needed to for a canonical class. Here you retrieve afficher info you had before when it wasn't a canonical class, and here you have the class C. Normally you have I don't have, but you must have the destructor. It's not a good idea because I have the destructor. Yes, and you have the destructor. You have nothing to destroy. Could we have to? Could we switch to the slide, please?
Oh, wait. No. Okay.
You can share the whole screen. Because it's more convenient, no?
No, it's okay. I'll do that. So this one.
Yes, it's okay.
No, it's not showing.
It's not possible.
No, it's just showing this one, I guess. This one. Manual. You can see it.
Hello.
Oh, yes, you see.
Yes,
Yes, it's okay.
we can see the slides. Yes,
Yes,
but
that's why you.
Oh, what? You can see whole screen or just a slide.
all the screens.
Now, the whole screen.
Yeah, it's okay.
Yes, okay. Now I will like you. You provide this name and these two functions, and I ask you which special method of rectangle class is called in line 10, 11, 12, 13, 14, 15, and 16. You have the canonical one, the canonical class rectangle, and I want to know which methods are called in this line.
Yes.
Alors,
Okay, it's not
10, line
10.
10.
Exactly, line 10.
which one?
Construct.
Constructor, yeah. We have defined two constructor in rectangle. So
Yeah.
which one?
Sweet constructor you have
Three.
by default, by exhaustive and combined constructor. Which one? Yes, by default. This one. Yes, exhaustive constructor. It's called exhaustive constructor. This one, assignment constructor. Constructor. Okay. Assignment. RH, so one. This
Copy.
assignment operator, yes. This one, function one is here.
It's from this one. What's the question?
Which which method do you call with function one?
Fish info. Method?
No. I take parameter R2 and I give to function one. Okay? Function one with parameter with R2 parameters. Okay? And I want to know which special method you call.
No, I don't get it.
The one on line 10.
Yeah.
The same one of line 10. The same one of line 10.
No, it's
not the same of line 10. Not.
Because
What do you do when you give a parameter to a function?
it's a copy, because you make a copy by value. So it's
Yes, a copy
of-
by value. So you
Okay, you pass by value, so
by
you
value.
need to call a copy by value.
Yes.
A copy operator.
Yes.
Okay. Because when you call a function without a pointer, you have to make a copy. So you have to find a way to make a copy.
A copy, yes, an assignment.
So internally it's another
It's
rectangle.
another one.
It's another rectangle.
Yes, because you put here your rectangle, you put it in the heap. Okay, in the heap you have you must to copy, and here is a little bit tricky.
Nothing.
Yeah, good. You call nothing because you put in the address.
Yes.
And you call nothing. And now you have
16 lines.
Attends. Comment tu fais pour passer ce next slide? Yes. You retrouve what you. Ah yes, I forget it. For return, I forget to ask for line 16.
Destructors.
Destructors, yes. And you.
That's the same question. Catherine has posed make the question. The destructor is called automatically or is called a few times later?
No, it's called automatically.
At the,
Automatically. It's like the constructor and the destructor are called automatically.
yeah, and
You
destructor
can
is like
never
Now,
call
no,
them.
there's no some delay between the and the function. You know, where is another language, the object is not accessible, it's reachable, but this is distracted a few time, a few seconds later, not right away.
Are you speaking about languages with garbage collector?
Yes,
And so
there's no
So-
garbage collector here.
yes, there is no garbage collector.
No,
garbage
there is
collector.
no scale. No. No, no.
It's right.
Now it's yours. You continue?
Yeah.
I put the slide back.
Now I was like, okay. Okay, so it's a derived class. Before going through this, I just made up a small example. Can I just go through one example? I will continue with this derived class afterwards because people are having trouble. So
I don't see what we see.
no, it's okay.
Yeah,
Just an example. I will go through this slide afterwards. So I just made up an example. I was talking to Sandy and I was like, oh, I can give this example. So here is a kind of example to understand object-oriented programming. It's like we know code. I mean, some people say it exists, some people say don't exist. So I am not talking about that. I'm saying like, okay, if it exists, for me, God is a kind of good programmer, good object-oriented programmer. So just consider him like a programmer. And on Earth, he has created a class called human being. And then he inherited class like some, how do you say, derived class like female and male. So in main class human being, he has some kind of function. He has some data members, like data members, you can say some features we have like eyes, nose, ears. So these are common, and some functions like we eat, we sleep. So these are kind of functions. So we can say it's a class human being. And then here female and male. So there are differences between male and female classes because they are, yes, of course, we are inheriting the functions and data members from the human being, but also we have our own data members, like our anatomy is different. The male and female is different. And we have functions as well, which are different in male and female. So, as you know, so this is kind of inheritance, you can say. Now here comes about thing is polymorphism. Polymorphism, yeah, I was talking in restaurant, like I can explain polymorphism now. So it's a kind of thing like we have mouth, we have teeth, and we take like a different kind of food. If maybe liquid, we have wines, we have milk. So it's like when we are having some solid kind of things, we are using our teeth, and input is different. So we are using our mouth, but with teeth, we are grind that and we eat it. And we have liquid like milk or wine or beer, then we are just powder like lips, and we are using the same thing, and we are ingesting that thing inside our body. So it's a kind of polymorphism example that I think works. I don't know if I explain well. So yeah, and there is another thing is abstraction. Abstraction is like, of course, we have our own function, we have inherited from how do you say, class, but there is some functions we can say like not visible to each other. Like I'm talking right now, but something is going on in my brain. Some neurons are doing something, and signals are passing, and those signals are converting into my voice, and I'm just speaking. And this voice is going to your ears, and then it's going inside your head, signaling. So it's kind of abstraction. I mean, God wanted to hide some information like how this process happens, so he made that encapsulation, abstraction thing. So I would just, I'm just saying like, okay, I can present this thing. And yeah, and sometimes it's like polymorphism and overloading, kind of like people say it's, how do you say, confusing, because it seems same, but it's not. I mean, in overloading, you have same name functions with different parameters. In polymorphism also you have like that. But in polymorphism, when it comes to class, we are using polymorphism. Then it means the derived class is acting like a base class. So it makes like a, yeah. And we are for objects, I would say we are objects. Like Valerie, Vanshi, and is a kind of objects. So that's a basic, explanation I thought I should give to understand the object-oriented programming. So yeah, it's a time for coffee. We can have coffee now. Yeah, we will start with this afterwards.
It's okay.
Yeah. Okay. Manuel?
Yes, Manuel, wait.
Yes.
There is a coffee break.
I'm successful to stop.
Class, or you can say inheritance. So it's like we are inheriting a class or some members or functions from our base class. So here we are declaring new class, but from the base class, the original. Here's the syntax for that class, your derived class name and double dot, and then your base class here. So here I have declared the person class, like it has person, has family name, and has given name. So it's a kind of constructor we are using here, and then we are using family name. It returns your family name. It returns your given name. Here it returns your full name. So, and here these are protected data members. When we have our inheritance, so I have put half slide for without inheritance class and half slide for inherited class. What is the main difference? In without inheritance, we have declared all the functions again, which we declared in person class. But in inherited class, we just call that it's inherited from the person class, so we don't need to declare the functions that we already have declared in the base class or the data members. We can just declare another function that we need to declare, or we can call those functions, and we have its own data member here. It's like student ID. Let's see this one without inheritance. So as in person, we have declared like student should have its name, like first name and family name. Here is the same function like it was in person. We are returning family name is the same. We are returning given name is the same again. Here we are returning full name, so it's the same again. So I would say, and here is just a new function. It's a student ID which we are returning here, and we also declared the data members here, all the 3 data members instead of just one. But in inheritance is a thing like we are not using any function or data members from the base class. We are just declaring the new things in this class. Next, we have types of inheritance, like we have public, protected, and private data members when we declare the members. So we can also use these 3 specifier to inherit the classes. Like there is a class for A. I've just put class A. We have public, protected, and private data members. Now we are inheriting class B from the public class A, but using public key. So we are here see that the data member X is public, can be used by class B, and Y is protected. Since it's inherited from the class A, we can use that data member as well here. But Z is private in class A, so we cannot use that in B because it's private. It's only used by the class A. In class C, it's protected. So since it's a protected inheritance from A, so the public data member of the base class is act as a protected member. So, and protected member also act as a protected member. But JAG is like a private. It's not gonna be accessed by this class. For the D, it's a private A. It means we are inheriting class D from class A in a private mode. So every member or every data member which are like public or protected in class A work as a private, but Z is not accessible by D. It's because it's private in A. So you have to be short like that. So here is a table about inheritance, how these things works with this. So it's a kind of table representation only. Polymorphism. So polymorphism is a work in different contexts, but it's like a same meaning, you can say. It's just a parameter difference in the function. Yes, again, it works as a overloading, like function overloading. You can say yes, it's a kind of same, but it is not same. I'm saying like it again. In terms of classes, we are using polymorphism. Like if we are inheriting any class, like from, you say there is a bird class, we have just bird can fly, and we have class like parrot or crow or some another kind of bird, and we are say this bird is fly. So this class, this bird class, or is work as a base class. So it's a kind of polymorphism, we can say, in terms of classes. So for the second talk, here's a conclusion. Like I hope you get the basis of classes and objects, how to use them. And polymorphism is a main function. It's give you like a broad view, and it's you can use in different contexts. And it's with polymorphisms with inheritance is really important. You can use them like a base class. So this is it. So part 3 is a virtual function and exception. I will go through that. The outline is like I will tell you about virtual function, then abstract class, then constant modifier, it's a constant term, and inline function. Then we will discuss about exception and exception handling, error handling with exceptions. First, virtual function. It's a virtual function are like when you have to go through the polymorphic behavior, then these functions can be used. And these functions, when you are going to use this function, you have to use virtual keyword in front of your function. Yeah, if you have virtual function in your base class, then it automatically called by your derived class. You don't need to define that, but they can be override. So you can override this class. And here is a kind of declaration you use, like there is some kind of function in there, and you can use virtual in front of that. I think you have a question. I'm just presuming.
I'm just wondering if I will understand with the next slides.
Oh, okay.
Just waiting.
No, I thought you have some questions. So sorry. Okay. Is the same I wrote in previous slide. Like if you have to make any function virtual, you just use virtual keyword and use that as a virtual. Yes, again, this thing, like you don't need to repeat the virtual keyword in every derived classes to call the function like it's virtual. And yes, virtual function can be defined in class where first declared. I mean, it's like a pure virtual function when you use constant keyword equals 0, but we will discuss this pure virtual function later. So, and here's a, yeah, it's the same thing I repeated again, like when you have inherited class and you have virtual function in your base class, then you can override that virtual function in your inherited class. And
maybe I have a question.
Yeah.
Does that mean that to overload a function in an inherited class, the functions that you overload must be virtual? I mean, that you can do this if your function is not virtual.
Yes, you can do it if your function is not virtual. But virtual, when it comes to virtual, it means more or less means runtime polymorphism. So it's a dynamically polymorphism. So I don't know if
No, in fact, I don't understand, but probably we will have some examples.
so yeah, so if you are using the same function like a virtual function and in base class, and you are using the function in derived class, then it will act as a virtual, and it should be the same function with the same name, same parameters, and you are doing something else in derived class, then it will override your base class function. So here is an example of virtual function. Here we have person, again it's a family name and a given name, and then we are printing here its name, and here it's a student class as well, and here we have the same print function. Here it's a virtual in the base class in person, here it's not virtual in student class. So when we are gonna call person, it will call this virtual class, and if we are going to create object with the student class and we call print function, so it will override this virtual print function with this print function. So here, sorry. Yeah, here I just created another function called process person, and here just calling person any class and printing this thing. And here is a driver code. I'm creating two objects here, person and student. For person, I just put Hishibari like his name, and for student, I have also a student ID there, and I'm processing both objects there. So for process person P is a person object, so it will call this print option, the first one in the person class. And in the second one, when it calls like student S object, that's a student object, it will calls the print command, print function from here. And so it's the same function, but it's overriding this function. Now constructor, destructor, and virtual function. Normally when we are using inheritance, then in classes, how we say it, inherited classes, we need to define the destructor should be virtual, pure virtual. So it's like virtual destructor equals 0. So it should be pure virtual destructor. And yes, there is a kind of thing, I mean, it might be free. I mean, why we need destructor? Actually, we don't need destructor if you are using a pure destructor. I mean, it's a kind of, I don't know how to explain this, but it's a rule that I don't like about C++. It's just like we have seen canonical classes where we are defining constructor and destructor. So we normally don't need destructor. If we are using virtual class, then we can like think so. Anyways, just C++ all day. So normally in inheritance, you cannot inherit your constructor and destructor. You have to define your constructor and destructor in inherited class separately. So, and it's a really, really bad idea to define virtual function or virtual thing inside your constructor or destructor. Yeah. Huh?
No.
Okay. So, yeah, it's a thing, just written everything like this. There's a example with non-virtual destructor here. So you can see I'm just deleting buffer and this thing. Now the problem is here. I mean, we have process new base. We are like calling base here, this one, and then we have derived class process new drive. So when we are calling base class, so it's like it's using the drive function and it's deleting the buffer. But in process new drive, it leaks because it leaks the memory. It's invoking the base class thing because it's not virtual. I don't know if I'm making sense or not. So
if you call the base class,
mhm.
it will run the base descriptor
Yeah.
and not no, you don't
Okay.
do something.
Okay. Here I have base class.
Yeah.
And it's not virtual. And I'm inheriting this tribe class from the base class. And here I'm doing tribe class and deleting this property.
Okay.
Right?
Okay.
Okay. Now I'm here like calling process is a base class here, and it's a base class object. It's base to base class. And here I'm just deleting this
Okay.
class
As this concept like only a base class.
Yes, it's a kind of it's invoking the base class destructor here. Since it is not virtual. So here when I'm calling new base from the base class, it's calling this one process because we are calling process and base class object. So it goes there.
This one.
Yes.
This one.
It's a calls destructor.
Okay, and it don't go down the hierarchy to check is that only the structure.
Sorry?
When in the second case, when you
Here,
yes, here.
Here, yes, it goes there, but it's a problem because here we have base, so it again invokes like base class destructor. It doesn't invoke this destructor because it's not overriding this thing. It's a like if it has virtual here, it will override the function like this one.
It's tricky.
Yeah. Yes, it is.
So, and the good practice is to declare virtual.
Yes, if you are using inheritance, then it's a good practice to use virtual and destructor.
Is there any reason? I ask this because it's a long time that in our Euclid templates, I see that the destructor are virtual, and I didn't know what it was. So my question is there a reason why a destructor should not be virtual?
Should not be virtual. No. I mean, no. You don't need any destructor if they are not virtual. Because compiler itself create the virtual, I mean the destructor, and normally it works fine. So if it's virtual and you are inheriting your class, then it's useful.
And if I don't inherit, it's not useful, but it doesn't harm.
It doesn't harm, yeah.
And the Euclid coding standard, it's the main thing.
It is in the template. When you create a new CDP class under element, you have this, the virtual destructor. It's 1 year that I'm wondering what it was. So I'm happy now.
Okay, I'm happy you got the answer. So here is the corrected one. If we put virtual there, then it works fine. It's just a virtual thing. So pure virtual functions. So sometimes I mean, it's not just destructor thing, but sometimes we need some functions should got like override again and again at every time, not just once. Like we had previous example for virtual function. So it's a pure virtual function. We call them and override them. I mean, you can use in any derived class and you can override that. I mean, sometimes you just have virtual and your function, then in some derived class, you just call that and you can use that virtual function instead of creating your new function and override that. But if you are using this, you can do it in every class. Like you have to define it like this. You have to use equals to 0 and just put equals 0, it becomes pure virtual. So yeah.
So in your parentheses, what is it?
What do you mean?
The thing you have to add at the end of the line.
Yes,
I can't see if it's a 0 or if it's parentheses.
No, it's a 0.
It's a 0.
Yeah, it's a 0. Like in your destructor in elements, you have a virtual destructor equals to 0.
Yes, probably.
Yes, so it's a pure kind of virtual destructor. So abstract class, what is abstract class? Which has one or more pure virtual function called abstract class and cannot directly initiate object of abstract class. I mean, and it that classes derives from the abstract class need not override all the pure virtual functions. I think I can show you example. You will be better with that. And I mean, these abstract class normally are like interface, like you have used your rectangle.h kind of thing. It's just an interface for the class. I can show you example will be better. So here we have class shape, which is an abstract class. And now we are inheriting rectangle from the shape. So here I have defined here one function is like just to check is it polygon or not. So it's like virtual boolean is polygon and constant 0 is not going to change. Virtual float area to get the area and constant 0, and it's a destructor. It's all virtual here. Now I have derived class rectangle and which is derived from the shape. Here I'm using rectangle, float w and h, width and height. Okay, it's just a constructor here. And boolean is polygon is overriding this function here and it's returning true. It is a kind of polygon. Here we are computing the area of the rectangle, so it's also overriding this function from the base class. And then it has its data members. Again, there is another class which called circle, and I'm using constructor again here. And then I'm also using the area. I'm calculating area here, so it's again overriding the base class function. And here also is polygon is also overriding that function. So it's just to use the function from the base class and overriding according to your requirements. And here, yeah, I think you know that in Euclid it's already defined. Virtual destructor example.
I think in the Euclid template, it's virtual destructor equals default, I think.
Yeah, it's a 0.
It's the same.
It's the same. So yeah, and you have inline as well. So okay, next is exercise. Okay, I will tell you about the inline later. I mean, how it works. So it's a time for exercise.